Another type of inequality you might run into is something called a rational inequality. The good news is it's going to kind of follow the same steps that we've been doing for a lot of our other inequalities. So just like before, let's go ahead and get ourselves some steps to follow and then see how to actually approach these. Like step one, we're going to change it to an equation. Again, the idea for this is I know how to solve a rational equation, then we'll just modify it into an inequality as we move along. So as we do this, I'm going to put some of the steps for solving the rational equation in here because we need them, and then we're just going to finish up with solve. So when we solve rational equations, the first thing we want to do is factor all the denominators to find the LCD. So just like we've done in the past, factor all the denominators, figure out what the LCD is. Now step 3 here is we're going to set the LCD equal to 0 and solve. These values go on a number line with open circles. Okay, that's kind of what we needed for the extra steps. So for the rest of this, step 4, I'm just going to just say solve. Put these values on the number line. Open or close circles depending on the inequality. Thank you, you can still see that. Okay, so once we solve it, whatever values we get from solving, we're going to put those on the number line as well, but those are going to get open or closed circles depending on what the original inequality says. Just like we've done in the past, we're now going to pick test values from each region. And I'm just going to say shade and use interval notation. All right, kind of stuck down there at the bottom. All right, so the last sentence says, or last 2 sentences, we're going to pick test values from each region, just like we did with our polynomial inequalities. Plug it in the original inequality, and then we're going to shade and use interval notation. Okay, so let's see how this works out. Let's just try a couple of these, because I know it looks like we got a lot of steps over there, but these actually aren't too bad. So let's just say our directions say solve or solve, graph, use interval notation. There's a couple of different ways they can word this. So let's say that I got x plus 5 over x minus 3, and I want to know when that is less than or equal to 0. All right, first thing we want to do always is classify this. This is a rational expression on this side, so this is a rational inequality. So following our steps, the first thing I want to do is change this to an equation because I know how to solve rational equations. Step 2, factor all the denominators. That's done. Find our LCD. So this part's a little bit of, it's x minus 3, a little bit of side work. So we end up with x minus 3. Over here on the side, you want to set that equal to 0 and solve. So here we get x is equal to 3. So on our number line, I'm going to come over here and say, okay, there's 3. Now, since that's the value we got from setting the LCD equal to 0, that always gets an open circle. Just think about it. To be a solution, you have to be able to plug it in here. Well, I'm never allowed to plug in 3, so that value has to always get open circles. All right, let's go ahead and solve the rest of this now. We multiply through by our least common denominator. X minus 3 times 0. That's weird. All right, so on this side they reduce, so I get x plus 5 is equal to 0. Well, that's easy to solve, so we get x is equal to negative 5. Now we also put all those values on a number line, say there's negative 5. But now this gets an open or closed circle depending on the original inequality. So this inequality has the equal sign, so all values from solving get a closed circle. Right. Like we've seen in the past, that breaks our number line up into 3 different regions. So let's pick a value from each region, say 0 and 4. And for each one of those red values, we need to plug it into this original inequality and see if it is true or false. So let's see, for the first one, that gives me -6 plus 5. -6 minus 3, is that less than or equal to 0? That's -1, excuse me, over -9 is 1/9 less than 0? No, it's not. So over here is false. If we plug 0 into there, I get 0 plus 5 over 0 minus 3. Is that less than 0? Well, -5/3 is less than 0, so this is true here in the middle. Some delineation there. Now let's see, what's the last number I said? Let's plug 4 in there. So I get 4 plus 5 all over 4 minus 3. Is that less than or equal to 0? 9 over 1. Well, 9's not less than 0, so that is false again. Okay, so for each one of your test values, you plug it in the original inequality and see if it is true or false. So you can see our only true region is right here in the middle. So interval notation goes from -5 to 3. We're including the -5, but we are not including the 3. All right, so that's it. So a lot like what we did before. The only difference is we got to watch out what makes the least common denominator equal to 0. All right, let's take a look at another example. Be a little bit harder. So let's say I got 2x plus 3. Let's do x plus 4 is greater than 1. All right, again, we want to classify this. This is a rational inequality. So following our steps, the first step says go ahead and change this to an equation. So we have 2x plus 3, x plus 4 equals 1. And then we got to figure out what the least common denominator is. So factor all the denominators, that's done. So it's easy to see, kind of like the last one, our least common denominator here is just x plus 4. Do some side work, set that equal to 0 and solve. We get x is -4. Give myself some room here. So we're going to take our number line, and we're going to put that value on the number line with an open circle. Let's put it right there, so -4, open circle. All right, so now let's go ahead and solve. We use our least common denominator to clear the fraction, so we multiply both sides by our least common denominator, which is x plus 4, times 1. On this side, the x plus 4 is reduced, so we have 2x plus 3 is equal to x plus 4. All right, this is just a linear equation. Get all your x's on one side. X plus 3 is equal to 4. Everything else to the other side, so we get x is equal to 1. Now, these values go on the number line with an open circle or closed circle, depending on the original inequality. So let's see, there's our 1. Since the original inequality does not have an equal sign, that gets an open circle. Just like before, this breaks the number line up into several different regions. Let's pick some test values. I don't know, 5, 0, and 2. Pick any number you want from the region. I generally pick the smallest numbers that I can. We're going to take each one of those red values, plug it into this original inequality, and see if it is true or false. So just for a little bit of practice, do me a favor, hit pause real quick. Go see if you can test all those values and figure out which regions we're going to shade. All right, you're back? If you're back, let's see how you did. Now, I'm not going to show the side work because hopefully you went ahead and did this. If we plug in a -5, we should have got that this is false. If we plug in 0, it's true. If we plug in true, it is also false. So that'd be 4. Is that right? All right, well, I'm not sure. Let's go ahead and try it. Just to make sure, let's see how we did. I'm pretty sure those are right, but let's go ahead and, oh, actually, those are wrong. I looked at it wrong. Let's try it again. Let's go ahead and plug it in. So if I plug in -5 for the first one, that's 2 times -5 plus 3 all over 5 plus 4. Is that bigger than 1? So that's -10 plus 3 all over 9. Is that bigger than 1? That's -7/9 Negative's not bigger than 1, so this is false. All right, if we plug 0 in, that's 2 times 0 plus 3 all over 0 plus 4. Oh, I messed up. Everybody watch. Making mistakes everywhere. That's going to be negative 1. That 7 is bigger than 1. That is true. So I had it right. I had it right. So true. When we plug in 0 here, we get 3/4 is bigger than 1. So this one's going to be false here in the middle. And let's plug 2 in there. So this is going to be 2 times 2 plus 3 all over 2 plus 4. Is that bigger than 1? So 4 plus 3 all over 6. 7/6 is bigger than 1, so that is also true. So hopefully you had an easier time plugging in the numbers than I did. I screwed it all up, but here we go. So let's see what our regions are. We end up with a true region over here to the left and a true region to the right, and it false in the middle. So let me get rid of my scratch work so we can actually write the interval notation for this. Since it has 2 regions, there's 2 regions that we need interval notation for. The region over here on the left goes from negative infinity to 4, not including either one of them. And this region over here goes from 1 to infinity, not including either one of them. Since we have 2 regions that include our solutions, we need to put them together with the union. So put the big giant U in the middle. All right, solving rational inequalities, quite a bit like solving rational equations, except for we still need to do that side work by setting our LCD equal to 0. But those values go on a number line with open circles. Any values you get from solving go on the number line with open or closed circles depending on the inequality. Test the regions, shade, use interval notation.